Welcome, everyone. My name is Catherine Ryan. I'm the head of marketing here at Skyline, and I will be hosting today's webinar. Some quick housekeeping points. We are aiming for about 20 to 25 minutes of content, as well as some time for questions at the end. Please submit questions using the questions area on your GoToWebinar dashboard, and our presenters will be happy to answer at the end. Also in your GoToWebinar dashboard is a handout of the case study associated with this project. This webinar is being recorded, and everyone who registered for this event will receive a link to the recording via email later today. So let's get started. Today, we are going to take a look at one of the most fascinating places on Earth, the lost city of Petra, Jordan. In 2018, Virtual Wonders visited Petra with the mission to create an accurate digital model of the ancient city. The team used drones with 3D cameras to capture both street level and aerial images of temples, theaters, baths, villas, and homes, many of which were carved right into the rocky sandstone cliffs. To stitch the thousands of images together and create a digital twin of the city, the Virtual Wonders team turned to Skyline Software Systems Photomesh. The result is a truly stunning digital model of Petra, Jordan that you have to see to believe. Today, we have Mark Bauman, the president of Virtual Wonders, and Itai Ben-Schechter, the director of production at Skyline Software Systems, here to talk about this amazing project. So welcome, guys. Thank you so much for being here. We have on our agenda today, Mark will talk about the operation and data collection at the site, as well as logistics and planning. And then Itai will talk about the Skyline approach to variable resolution and altitude data processing, and really utilizing the 3D data inside Terra Explorer. So to start us off, we've got a video to share of the Virtual Wonders team on location in Petra. And I believe Mark will take it from there to talk a little bit about Virtual Wonders. So enjoy.
Hello, everybody. I'm Mark Bauman, the president of Virtual Wonders, and we are a collective of explorers, technologists, and storytellers. A lot of us met at National Geographic and did some of our first 360 imaging and scanning there, but we now work on sharing and protecting the world's most special places. And we digitize them at hundreds of times the resolution that any modern display system can handle, so that we can hand off preservation data sets to the governments involved and then create best-in-class media. As you can see at Petra, we did a lot of LiDAR photogrammetry. I don't want to go into too much detail on all of our techniques, but generally speaking, we use multimodal scanning and a lot of technologies to build these 3D models, sometimes textured light scanners, a lot of aerial photogrammetry, etc. Petra is one of the 7 wonders of the world, and I've been to most of them, and I have to say it's my favorite. We were there in partnership with and at the invitation of Princess Dana Faras, who runs the Petra National Trust that's charged with maintaining Petra and making sure that it's there for future generations. And we share our data sets with them on all fronts and are working with a number of media companies to create experiences in AR, VR, potential video gaming experiences, virtual film sets, etc. In the last few years, well, in the last few months, actually, because of COVID, we're working with a lot of Hollywood studios on bringing virtual film sets back to virtual studios, because given the risks around COVID-based production, travel is at a minimum now. and our ability to bring sets back from around the world and around the United States, from extreme environments ranging from Mount Everest to the bottom of the ocean, seems to be in vogue across a number of industries. And we love working with you guys because it takes a whole lot of servers to put this together and some great software, and cloud solutions are often incredibly expensive. You guys are cost effective and you do an amazing job with aerial data. Itai, you want to jump in there?
Do you want me to start the second video, or?
Sure, we can talk a little bit about that too. Let's play it and then I'll talk about it.
Sounds good.
Since it's hard to hear the audio on this video, I'm going to talk a bit over it. These are our scans of the Church of the Nativity compound in Bethlehem in the West Bank. It's a worship site that dates back more than 2,000 years of its Christian history. There are 3 denominations at the site. The Greek Orthodox Church sits above the Nativity Cave, which is the original site of worship. And there's been worship in that cave, Christian worship in that cave for pretty much 2,000 years. There was some pagan worship at the site even beforehand. And what you're seeing there is the Greek Church. At the beginning, you saw parts of the Catholic Church. And this is the Catholic portion of the Nativity Cave. In a minute, you'll also see some of the catacombs beneath the site as well. This is the entrance to the Herodian Catacombs, where there are thousands and thousands of Christian martyrs. So it's an extraordinary site with incredible art and incredible history, and a lot of the story of Islam and Christendom coming together, because unlike a lot of other Christian sites, although there are many for which this is true, it has been under Islamic rule for most of its history. And what you're seeing there has only been possible in the last really few months, as Unreal Engine has made it possible to stream these massive point clouds. That, I believe, is the largest point cloud that's ever been streamed in Unreal. That version is at 15 billion points. We're now streaming a version of that point cloud at 20 billion points in Unreal, which means that you can do previs for video production and even 3D VR headset experiences in a raw point cloud before you do a lot of the final finishing on the data, which is great for production planning. It's great for planning AR and VR experiences, etc. And it is a huge leap forward.
Okay, let me jump into the display. So is there anything else you'd like to add, Mark?
No, I'm happy to take questions once you talk through the ways in which we've worked together on the aerial data.
No problem. And if anybody has any questions, feel free to post them in the Q&A section of the webinar, and we'll address them as we go along, or take a couple of minutes at the end to go through them. So I'll take you through the processing that we did using the data from Virtual Wonders, specifically on the Petra project, and what was done in order to be able to produce what you're seeing here, the full 3D rendering of the entire data set. So just to give you an idea of the variety of the images, and I'll make the icons a little bit smaller in a second, you can see the location of the images all the way from very high altitude data, all the way to images that are no more than 1 or 2 meters above the ground. Let me make the icons a little bit smaller. There we go. So now you can see the combination of images that are pointing 90 degrees horizontal. And we can see what one of these images looks like. All the way to images that were captured from a nadir perspective, facing down. Would be one of these images. So you can see the variability in resolution and data. One of the benefits of photo mesh, first of all, we could bring in a lot of different data sources all together and connect them into one single comprehensive aerial triangulation block, bundle block. And we can also enhance it by seeking out areas that we can use to tie together. And we use the resolution that is optimized for each triangle. So when you're looking at, let's say, the temple, where there is data that was captured, 1 or 2 meters away from the site, that's what's being used to create the geometry and texture of that specific triangle. And that's why when you zoom in, it brings in full resolution texture that was used from that image. And then when you go into an area that was captured from pretty far away, let's say this mountainside over here, you can see that it uses the best resolution possible to map out the mountainside, which could be very different resolution, but when you look at it, it all creates one single comprehensive view. So the nice thing is also, once you connect all the data together in the aerial triangulation step, if you look over here, it's possible to see that some of this data was collected early in the day, which when the sun is coming in from the east, this mountainside is shaded. And then a little bit later in the day, in the afternoon, the sun is on the west side, which means that this mountainside is completely lit. So if we look at one of these scenes, and I can show the photos that hit this point, let's say over here. And I'm using, by the way, this is Terra Explorer, which enables the visualization of the 3D data. And this is the Skyline Photo Inspector, which allows to view all the images that create 3D data. So this is one of the higher altitude images. And we can look at the image and see this is a view from the top. As we move away, you'll see this is one of the oblique images in full sunlight that was used to produce this point. And then if we go to one of the other images, this one, you'll see the same area but in full shadow. And this is the side of the mountain during the morning time, when the sun is on the eastern side of the mountain. So at the end of the day, this creates one single comprehensive 3D view. Now, once the data is in the 3D, there's a lot of additional analytics that can be done. This could be analyzed in order to see viewing points that were created with certain areas. So you could see, let's say, from this mountaintop, the ability to place yourself and then visualize everything that was visible from this site. You can see over here this mountain range. You can also do line of sight analysis and analyze what's visible from this point right here. So if I place myself over here in this spot, and then I can measure what's visible in this location, and this also helps analyze a little bit what was the design for a lot of these archaeological sites, what was the decision to build them in the way that they were built. Okay, so this is one aspect of the 3D model. And I also have the project viewed over here, so you can see how it was actually processed. This is our photo mesh software. And see, this is the AT tile that calculated 100% of the images in different views. Now, the nice thing about photo mesh is we can divide the project up as part of our mechanism into tiles. And then each one of the tiles is able to, according to whatever data is available for it. So over here, there will be very dense tiles with a lot of information. And this is the produced point cloud. And then for other tiles, there will be only 48 images. This tile could have 245. So as part of the process, we're able to connect everything together and create one single comprehensive view. So I'm getting some questions. I'll address them. There's a question if we can support VR. Yes. So the VR is built directly into the software. If it's connected to your computer, you could visualize the VR, the 3D data and everything on top of the 3D data. So any sort of GIS layer information that's being built on top will also be included in the VR view. And there's a question if we support SDE database data. So the question is yes, we support Arc SDE database right here, and you could bring in any one of the file formats also to be integrated and ingested on top of the 3D model. There's also, to address some other questions, there's all the basic 3D measurements are available. So let me turn on some of the measurements. You could measure vertical distance. This is one of the amphitheaters. Horizontal measurements. This would be also an aerial distance. And there's also being able to measure on 3D planes to get a very accurate measurement. And that could be either horizontal or 100% vertical. If we wanted to measure the surface area of this mountainside of this temple, it'd be as easy as this. And then I can measure it on an arbitrary plane. We also have a snapping tool, so I can snap to certain vertices in the 3D ML and then measure the full 3D area of the side of the temple, really anything inside the 3D view.
Itai?
Yes.
Let me jump in there for 2 secs and say that this is exactly what we love about your software and your server solution, and that we combine your connective tissue that brings together all of this aerial data with the interiors in each of those spaces, so that this experience is, of course, VR capable, but in most cases won't let you go inside the treasury, inside the monastery, inside the old Byzantine churches. But the lovely thing about that is that we can give you insane resolution inside those places and let you walk between them in an experience because of what you guys bring to the table.
Yeah, and just to mention, we've been working with Virtual Wonders on this, not for too long. We have been working with them quite a lot in the past, but on the Petra data set, it was a bit of a challenge that we took on. From what I understood, it was a difficult task to try to connect all of the different AT photos together. There's more of sort of solved in batches or groups, and the goal was really to try to create everything in one single 3D output. The next step, and that's actually what we're working with them on right now, is we do have the ability to ingest massive point clouds. And we've received the data sets for a lot of these sites, the indoor scanning for some of the tombs and some of the temples, is to integrate them initially as point clouds into the view. And that could also be part of the same comprehensive environment. And the second aspect would be to try to integrate them into the mesh creation so that you'd have a full 3D mesh. And essentially, if you're looking into one of these tunnels and one of these tunnels was scanned, you'd be able to go inside in the mesh and really move all the way from viewing something, 1,000 meters above the ground to being able to view it all the way inside territory. And we do have the ability to support walk mode or indoor navigation. So this is something that we're really excited about, and we're pushing the software in that direction. And Virtual Wonders definitely has the right data to develop the software on and challenge it into that direction. We're very excited about the collaboration. And just to reiterate, this is images only. This did not have the LiDAR included in it. This is 100% the AT images. Okay, I'll address some other questions. Is Unreal Engine necessary for the creation? No, this was produced 100% with Skyline Photo Mesh. And the benefit of Photo Mesh is that we're able to utilize really hundreds of computers if necessary. And see, this is our internal production where we run about 75 machines, but we can also plug into AWS and bring in, I think we've ran a project on up to 500 computers in parallel for really quick turnaround and really massive scale.
Let me jump in there for a second, Itai.
Yes.
Unreal Engine and Unity, as most of you I'm sure know, are the main video game engines, but they're now also the production tools of choice for both film and television. And the reason that we tend to work in Unreal these days is because of all the lighting tools and because of the ability to stream even interior massive data sets as raw point clouds so that you have an output really early in the process that lets you do production planning and video game engine planning, film planning, etc. And you can do virtual camera moves through any of it. A lot of that can be done here, but the lighting tools and all of the other bells and whistles that are critical for Hollywood production and video game production are built into industry standard software packages. And the great thing about this data is that we can drop it into those packages pretty easily.
Yeah, and yeah, our goal is initially at least to focus on the content creation, being able to bring all this data together comprehensively. Obviously also being able to visualize it in Terra Explorer and give it a geospatial sense has a lot of benefit to it, but we're also working on the best way to integrate it into the formats that are ingestible with the Unreal Engine and Unity, and that's something that we're working on with the Virtual Wonders team as well. I see there's some questions on that, so this is something that I just want to make sure that people are aware of. And there are open industry formats, and that's actually what we're working on, to being able to produce it directly out of the photo mesh output or export it out of Terra Explorer with our mesh conversion tools. Okay. So we're very excited. There's a couple of other projects that are in the pipeline with Virtual Wonders, and we hope, when things open up a little bit and they can actually continue with some of the data creation or the data collection, we'll continue supporting the content creation part and the 3D creation. And at that point, we will be more than happy to share some of the results, of course, with Mark's agreement. Mark's permission, and maybe do another webinar where we could show some of the other outputs that we've been able to produce.
We love working with you guys.
Oh yeah, it's I think a great synergy between what you guys do, and this is definitely something that we're working towards. Variable resolution, integration of LiDAR and imagery, indoor, outdoor. So you guys are the perfect partner for our software. Great. So Catherine, is there anything else you'd like to add?
I just want to make sure that we got all the questions in the box. And if there's,
so.
if anyone has questions that they think of later, please connect with us. There'll be a link and an email address in the email that I'll be sending out shortly. But I'm happy to answer any other questions that you have. We should be sending that email in the next couple hours. It has a link to a recording as well as a case study associated with this project. The recording will also be available on our YouTube channel as well as www.skylinesoft.com, our website. So thank you all so much for attending, and hope you have a safe and wonderful day and rest of the week. Thank you guys both for joining us, and it was really fascinating. Thank you.
Thank you.